Hi everyone, welcome back to Fat Cat Maths. Today we're going to be looking at nonlinear simultaneous equations. Let's start by looking at the difference between linear and nonlinear equations themselves. Linear equations are anything that make a straight line on a graph. A quick way to tell is by looking at whether there is a power after either the x or the y. If either the x or the y are squared or to the power of something higher, you're not going to get a straight line. Nonlinear equations are the opposite, so anything with a square or a power of something higher on either your x or y will form a curved line or a circle. In the exam, you will either be given a set of linear simultaneous equations or you'll be given one linear and one nonlinear. These are solved very differently, so it's really important to understand the difference. Being given a linear and a nonlinear simultaneous equation is only found in the higher paper, so if you're doing the foundation paper, don't worry about this method for now. Let's look at why they're so different. When you're given two linear equations, these are two straight lines, and you're trying to find the point where they intersect. There will be one solution for x and one solution for y, and when you put these two together, you get a set of coordinates. If instead you are given one linear and one nonlinear equation, if you imagine a straight line with a curved or a circle line on top of it, you're not just going to have one point of intersection anymore. You've got two, which means that you're going to have two sets of coordinates and two solutions for x and two solutions for y. The method can seem a bit tricky at first, so we're going to use a worked example and go through it step by step. Here we can tell that we have one linear and one nonlinear equation. We can tell that because the x and the y are to the power of 2, which means that when plotted on a graph, it will be a curve or a circle. The first thing I want to do is look at my linear equation, which is the one on the bottom. I want to make either x or y the subject of that equation, so I'm going to move the y onto the other side by changing its sign. Now x is the subject. Because we know that x equals 6 minus y, we can replace the x in the nonlinear equation with 6 minus y. So if I rewrite this equation where x is now 6 minus y, I have 6 minus y in brackets squared plus a y squared equals 20. After expanding the set of brackets, I will have 36 minus 6y minus 6y add y squared equals 20. Now we can simplify by grouping the similar terms together. When that's simplified, I will get 2y squared minus 12y plus 16 equals 0. You will have seen equations like this before when we're being asked to solve a quadratic, and that's exactly what we need to do here too. I have a few other videos for solving quadratics, so I won't go into too much detail now, but the links will be below. The best way to solve this particular quadratic is to factorise. I need two things that times together to make positive 8 and add or subtract to get minus 6. The solution to this would be a minus 2 and a minus 4, so to factorise I'll put that in two sets of brackets with y minus 2 and y minus 4 equals 0. When I'm solving for y, I take them out of the brackets by changing their sign. I now have my two solutions for y. Y either equals 2 or y equals 4. I now need to find out what x equals when y equals 2 and what x equals when y equals 4. I can do this by replacing the y in my second equation, x plus y equals 6, with either 2 or 4. By doing that, I can see that when y is 2, x equals 4, and when y is 4, x equals 2. So we have two sets of coordinates and that question is done. I know that might seem a lot, so let's just go over some steps so that we can tackle it systematically. The first thing you need to do is substitute what x or y is into your nonlinear equation. Secondly, you will have produced a quadratic by doing that, you need to solve it. Third step is to rewrite your equation with what you now know to be either x or y. And then lastly, solve again. Let's try another practice question. Here I have 2x minus y equals 7 and xy equals 15. xy equals 15 is nonlinear. It doesn't have any powers, but if you're doing an x times a y, you will still get a curve or a circle. Our first step is substitution. To do that, we need either x or y to be the subject of one of the equations. It doesn't matter which one you choose, but I'm going to go for y. Now I'm going to replace the y in the top equation with 2x minus 7. Once I've expanded and simplified this, I get 2x squared minus 7x equals 15. To solve any quadratic, it needs to be equal to 0, so I'm going to move that 15 over by changing the sign. When you're trying to solve a quadratic equation, the best method is always factorising, so try and do that first. Factorising works in this case, and I will get two brackets of 2x plus 3 and x minus 5. To take these numbers out of the brackets, you change their sign, so either 2x equals minus 3 or x equals positive 5. When this is simplified, we get x either equals minus 1.5 or x equals positive 5. The next step is to rewrite our equation with what we now know x to be as minus 1.5 or a positive 5. The easiest equation to do this with is the top one, so I'm going to replace the x with, first of all, a minus 1.5, and that tells me that y equals minus 10. Next, I'm going to replace it with a positive 5. And that tells me that y is a positive 3. So now my two solutions are minus 1.5 minus 10 and 5, 3. Here I have a nonlinear on the top and a linear on the bottom. My nonlinear equation already has x or y as the subject, so we don't need to move anything around. And I'm going to replace the y with 2x minus 3 in the top equation. Once I've done that and simplified, I get a quadratic of x squared plus 4x squared minus 12x plus 9 equals 100, and then when I simplify that again, I'm going to get a 5x squared minus 12x minus 91 equals 0. Factorising is normally the first thing that you should try when you're solving a quadratic, but there are two other options. You can try completing the square or using the quadratic equation, and with something like this, the best course of action would be to use the quadratic equation. I have another video for choosing the best method when solving a quadratic, so take a look at that link if you need a bit more help with that. To use the quadratic equation, you need to know what a, b, and c are. A is always the first number in your quadratic, so it will be a positive 5. B will be minus 12, the second number. C will be minus 91, the third number. Once I replace the A's, B's and C's in the equation with 5, minus 12 and minus 91, I will end up with this. This is telling us that x either equals 6, add the square root of 491 and all of that divided by 5, or x equals 6 minus the square root of 491 and that all divided by 5. With something like this, you would put that into your calculator and you would find that x either equals 5.63 or x equals minus 2.23. Then, just as before, we replace the x with what we now know to either be positive 5.63 or minus 2.23, and then we can find out what y is. So when x equals 5.63, y will equal a positive 8.26. And where x equals minus 3.23, y will equal a minus 9.46. Let's go over a quick summary. Remember, if you see the bullseye, this is a great opportunity to pause the video and take some notes for flashcards. In both the foundation and the higher paper, you might be given two linear simultaneous equations. The answer will only be one solution for x and one solution for y. In the higher paper only, you may be given a linear and a nonlinear simultaneous equation. Because we're working with a straight line and a curved line, you will be looking for two sets of coordinates, so two solutions for x and two solutions for y. With your linear simultaneous equations, you are looking to either add or subtract them and solve from there. But with your linear and nonlinear, you are looking to substitute and then have to solve your quadratic. Thank you, that is the end of the video. That was a very tricky topic, so well done if you're still here, and please hit that subscribe button, it would really help me out. I hope you have a lovely week, and good luck with the rest of your revision.